be discussing some basics about the Arduino things. I hope you are aware of how you can blink an LED, right? So usually, what are the steps we do to blink an LED in Arduino? What's the first step we do? You have to
Pin number.
yeah, we have to configure the pins. So we used to set up the pins. Like, this is the internal LED which is connected to this pin 13. So I am using that for now. And I used to set the pin mode as output and input for input. Yeah, so output. And we used to use the functions for doing things. Delay. Then we'll use digital write function to set the state of the particular pin. Here in this case LED pin. We can set it as high, then we can set it as low. This is the basic idea how you will blink an LED. Oh, is the code is not visible? Oh, I'm not sharing the screen. Sorry.
Hello, sir.
Okay, okay. Yeah, I'll share this. Yeah. So now this is visible, right? So this is the usual blink code, and you can see the internal LED here is blinking.
Sir, are you saying something? Voice is not.
Oh, how is my voice now? Is it better? Is it better now? Hello, Arthur. Hello. Am I audible?
Yes, sir.
Oh, so this is how you usually do things. So you know that this uh, sketch.ino that is present in every Arduino folder, like Arduino Sketch, as I used to call, is actually a C++ code. So what Arduino does is it does some kind of pre-processing and does this setup only once and this into loop. So after the pre-processing, the pre-processed Arduino file get converted to a CPP file, which will have a main function, as you know, like C, right? And we use these Arduino libraries to do things. So these functions in digital write, pin mode, delay, these are actually present in the Arduino library. So there is a standard library for them, where they have defined all these functions and all these constants too. But actually, what is this board? This is Uno board, as you know. So what is the main working component in this Arduino board? It is this microcontroller. So this controller, the name of this controller which is present in the Arduino is called Atmega 328P. So this is the microcontroller that is present in the Arduino. See this board is the microcontroller, and that is actually connected to these various pins. And if you see the actual pin diagram for this uh, microcontroller looks like this. So there are this microcontroller comes in different shapes. So Arduino has one of the shapes which can be easily put into a breadboard. But these are the two different alternate shapes that it comes in. And if you see, this has the pin numbers like this. So the actual micro controller has the pin numbers like PD4, PD1, PC6, PC4, and some ground, some other things like ADC6 and VCC and things like that, right? So these are the things that it has. So now if you see the Arduino's pinout diagram, so this is taken from the Arduino docs. So if you go and see Arduino docs, we get, sorry, this is docs for Arduino. We Arduino, Uno. If you go here, we'll get the docs for this thing. So I took out this pinout PDF, which is this, and you can see here. Actually, they have given these microcontroller pins and the Arduino pin names, right? So that they are, so this is that Atmega 328P that we know, and each of these pins here are actually connected to one of these pin in the Arduino board, right? And you can see these, actually these are starts from, this is starting from PD0 to PD7. So what is PD, PB, everything means? So those are ports. So there are this GPIO ports that we have. So in different ports, so there, these are peripherals, right? These are peripheral ports. So there are different ports that are there, which is a D port, which has this 8 things, 8 values, and there is this B, and there is also the C. The C port is actually used for ADC, which is analog to digital conversion. So we use these analog pins, right? So this is used for, this C ports are used for, and there are also this ports there. So these are the things that are present in our Arduino, right? So the other pins, so there is A, B, C, D, E, F, like, so many ports are there. Some of those are actually connected to this internal control systems. So that's why that are not available for our general purpose usage, right? So these are the pins that we have to use. So why do we need to know these names actually? That is one thing. So what Arduino has is, so when you compile an Arduino, it has this things such as you just have to put the pin number as 3, and it actually, what it does, it modifies a register. When you do a digital write of LED pin to high, this is more readable format, but actually what it does is it changes a register, right? So there is some register which is responsible for changing the value of that. So what are the libraries? So these functions are defined in Arduino.h, and there are certain functions that Arduino H uses to implement these things. So there are different libraries that are there, and one of those is AVR library. So this is AVR libc, which means, so this is the standard library for this AVR boards. So this microcontroller is an AVR microcontroller, right? 8-bit AVR microcontroller, and we have a standard library AVR libc, which has different functions that are uh, can be used in this microcontrollers. All this at Mega microcontroller, and our microcontroller is 328P. To be around here. This is what we have, right? So this supports all the AVR devices, this library. And if you see, what does this library have? So this is the source code of this library present in GitHub. And there are many things that are available here also. So we can actually program uh, this Arduino board without the Arduino code, without using all these functions, without using a sketch.ini. You can use mains.cpp to run actual code by manipulating the registers to bring the same in. So there are things like that. So how we can do that? So let me give you an example. So here, so there are some of, if you see this, there are this .h files that are defined over here. So what does this .h file contains? Basically, the register definitions for the particular microcontroller. So for example, uh, what is our board is 328P, which is this. And if you see, these are the register names, and these are the register bit names in some sense. So these are register bit values. So there is this DDP pins, DDRC pins, which is the data direction register, and there are these port pins and GPIO pins, and these are some timer pins, timer counter, timer compare registers. So these are different things that are present over here. All these values are this memory address are actually defined over here. So when we are using a particular board, you don't have to remember the actual address of the particular register. You can just use the register name to access it. That is the point of using this AVR library. And it also has some basic utility functions that will help us to code things. And one of those utility functions is delay. So these also have a delay thing. It is present somewhere around here. Tills. So where it is present, but let's check out here. Yeah, there is this delay.h where these functions are there. So this delay ms and us are actually some functions that this uh, library provides us, which is very basic thing. Arduino library provides a very higher level like code, right? But this provides kind of lower level code, and these are some utility functions that we can use to simplify the code. So let me write a program, the same program, but not without using sketch.io. So what we'll do is we'll delete uh, this file or rename this file to main.cpp. Okay. Now we have a main.cpp. So in the main.cpp, what are the things we need to have? We need to have a main function, and there should be something there. Okay. Now our aim is to toggle this LED. So now we want to find which is the pin that corresponds to this pin 13 here. So if you see the pin diagram here, we can know that it is PB5. We also this PB5 is the microcontroller pin. So that's why they have given this micro. And you can also find that over here. So micro means microcontroller name. The name in the. Now if you see, this is the data sheet for this particular microcontroller, which means all the pins, all the ports, all the registers, details about that, everything will be present here. It's kind of very large thing, but we don't have to go through all of this. We just learn what we want to know, right? So now what is the thing that we are trying to do is change the port, right? So the IO ports, the input output ports that we have. This is what we need to check out. So I'm going to this section. You can just navigate here easily. And this is the structure of how the GPIO port is, the circuit diagram and things. So usually we do configure this thing, right? Like the input or out mode that we used to configure. So there is this registers. So if you see, there is this register description. So after every description, every section or IO external interrupts, they'll have this register in description where they have different registers that are involved in configuring the particular peripheral. So here we are just seeing about the IO registers. So what are the different registers that we have? So this is the control register, and these are the name of the particular bits. So this IV cell, IVC, these are the name of the particular bits in a register, and this is the name of a register. So this is, since this is an 8-bit microcontroller, all the registers would be also 8 bits, right? That's why you see 8 values on here. So this is the port B register, and these are the actual pin names around here. So if you see the source code of lib.c, as we saw here in the IO for this particular board, which is IOM2P8 26P, right? It's 328P. Yeah, 328P, which is mm, this one. And you can see all that registers are actually different here. Okay? So the DDRD register and the DDR, these are the bit numbers, like the values. And if you see, for example, what we are seeing here, MCUR, MCUCR, this register, just MCU control register. So usually this register's name would be short form for what is they are doing. For example, this DRDB is the data direction register for port P, right? This is also pretty quite understandable in some sense. If you actually know the some specific short forms, it will be easy. That will be easy for us to work with that. So this MCRC is there, TDRT is also there. See, this is the port D register. So the port D register, what does contain? What does it contain? So the port B is basically every port is kind of similar, but it's a different port. That's the basic idea. You can see all these things, right? So here, port B and the port B have 8 registers. So, for example, in our Arduino board, we had this port D, right, and port B. So, setting a value. So, for example, this port PB0 is actually this port B0. So, this value. If you set this particular bit, you will see that particular pin turning on. So that's what that means actually. But that is the input, like the actual value. And there is one more thing you need to set, which is the direction register. So how do we configure these things like? And we also have this pull up, pull down things that we have. You may be aware of things. So there are different configuration that we need to do. So now you have this all these register names. How do we configure this? So that is the next thing, right? So there's here a section on configuring. So how do we configure that? So we have these three things, which is DDXN. So this is a general name. Like X can be like what? A, B, C, D, and N will be uh, sorry this uh, the actual value DDN corresponds to this register bit value. Just a minute, this one DDXN, which means DDBN. N corresponds to this bit. So X corresponds to, it can be A, B, C, D, E, F, anything. Right? So that's the general form of saying what a particular thing is. So this data direction bits will be there, and the port pin will be there, and this pin X will be there. So these bits, how do we configure things? So we have this different states. In output mode, we have output low and output high, right? Which is the low and high. So what do we configure? So for output low, which is the digital write 0, that thing. So for output mode, this is the mode, and this is the, in this mode, output mode, you want to configure as low, then you have to set the DDXN to 1. So basically, if you see, these are the input states, and the DDXN will be 0. So what does this mean? This DDXN bit says that whether that port is input or output, and this value says that whether it is low or high in output mode. In output mode, which is 1, if you just toggle this value, you will get to know whether that port is low or high. And this PUD that is present in MUCR, that specifies whether that input mode, so you can see these are don't cares. So whether when in output mode, we don't care about this PUD. But when in input mode, this PUD configures whether we have to pull up or pull down. So that thing is there. So you also know what the this pull up. There are different modes, right? We want to pull up or just input or output those things. So here, if you do this, if you set it to 0, it would make to pull up, right? So that is the idea. So now we know how to turn on or off the particular LED using resistors. So we can do this. So what I'll do? So we know this resistor, 7. Oh, okay. Let's take the LED 13. So what is that? From this LED 13 is PB5. So for the setup, we have to configure the pin, right? So now we can also set like this in the LED pin. So what is our LED pin? It is sorry, PB5, but we don't know what to do, right? So we now don't need that actually. We set using the DDR register, the DDRE register for the B port. So DDR sets the direction. So we have to set it to output. So DDRB, we'll set it to. So this is the register. DDRB is a register, but we want to set a particular value DDRB 5. Because since this is PA5, PA5 is the pin 13. T13, we can say. So to turn on that particular bit, you can use something like, you can specify it like this, right? 0x, the fifth pin. So 0, 0, 0, 0, 0. This is the fifth one, right? So 1, and this is the. I'm just setting it like that. So this whole thing specifies the input output this whole register specifies the input output configuration for all the P bins. This P0, 1, 2, 3, 4, 5, and there are some other pins also over here. The, that those are the only P bins. Yeah. So for P, those are the only things. So that 5 things configures the input and output mode for all these things. Right. So now we have set it. So now, what is the next thing we want to set? Usually in a while loop, we used to do this toggling, like the delay, using the delay, right? So what I'm going to do is, now this is our setup, and we use a while loop to create our loop function. While 1, while true, which means loop forward, which is similarly equal to our loop. But before that, since we are using these things, these are coming from the AVR libraries, we have to include those also. avrio.h. And, so this is avrio.h is the that file contains these register configuration as we saw, right? So there is this avrio.h. This file actually contains a configuration for different boards and which file to include. So if you are using that board, so if you see here, This has the definitions for which board, for this particular board, include this particular header file. So basically, this is a common area for selecting which particular board. And for our board, which is Atmega 328P, this one, it is defined in this file. So if I search that, that is this file, and that's where our register descriptions are there. So if I want to use these values, I need that, right? So that's why we are including it. And we are going to toggle the pin. So how do we toggle a particular bit in a thing? So now don't worry about toggling. So we just do this. Uh, we set and then reset. For example, DD, sorry, port B, we have to set the fifth pin. This is basically doing this, right? Then we have to create a delay. So for now, we don't have to include this delay and things. We just implement a rough kind of delay using another for loop. For loop, uh, signed long, I, I equal to 0. We'll just use unsigned integer. Let me try this. I less than, okay, I greater than some big number like uh, this, and this would fit in an integer. I'm not sure. Let's keep this. And an empty loop, and we are again going to turn off this port to be the fifth register. Right? Let's try this and see how it works. Since it like that, right? Okay. What we do is check whether outputs are coming from that. This one, using logic analyzer. And plug it somewhere here. If outputs are, it is changing. I think we have to add this also, right? This delay after this. Any output is coming from that, this will let us know. If the bit values are changing, we can see it with this. So let's run this now. See how that goes. Uh, maybe it is too much. This time is too much. So use this. Let's verify this one. So, okay, this is 0, 1, 2, 3, 4. We have to put the 5, right? So it is this one. This one. So 0, 1, 2, 3, 4, and 5. Now let's check this. Still no samples. And we have to configure this is configured correctly. Estimate. This is B5, and we are configuring the EB DRB21 and storage. See any values changing over there because this is too long. So this would be too long. Or maybe okay. That might be because of that. Okay, still. This into this. Okay. So we are shifting this up 1 and 1. So it should be high and 1 and 0. This is okay, I think this should work. Let me try with the delay function also maybe. Instead of using this loop, maybe leave that just in case. Just a minute. Yeah, make some. Okay, I think I have to call this function once I go in it. Okay, so there. Yeah, I will basically it's to separate that we have defined over here. Yeah, then that I'm not sure. We are just there. Doing this. Same manner. So I think it's set it to the output mode. Just listen to 10x. Okay. Just a minute. Okay. Just yeah. So there was just a minor mistake, and we'll start from scratch. Okay. So what was that happened this? I, instead of specifying it as 0b, what I did is I specified it as 0x, which is hexadecimal. Instead of setting bytes, I have set a different thing. So that's what happened actually. Okay. Now we'll do the same, like including area h, sorry, area.io.h, and include, this is the only thing that we need, int main, and we set up the pdrb 0p. So I used 0 x last time, so that's why it is not working. And now let's try this. While 1 port B to this thing, we are turning on that I, and the for loop, simple thing without delay, I 0 less than 1000 plus plus, and we are going to reset it, and we do this again. Now let's try how that is working. Okay, closing something. Okay, what we didn't close. There's I think this is our empty for loops. Yeah, it is turning on, and I think it's turning on. Okay, it seems this use of this for loop is taking too much simulation time. So what we'll do is use delay instead. This is overloading the simulation, so that's the thing. Without delay touch, and here we use the so for 500 milliseconds, and I mean the same. Now, yeah, this is fine. So now we have this, right? Okay, now we are good to go. So now we have implemented the first thing. So do we need to write it like this? So that is the next question. To setting a particular bit, do we have to specify something like this? What if we have multiple things that we want to turn on and off, and setting that would be like every time like this would be difficult. So let me show you what are the bit manipulation things that we can do to do different things. Okay, this is here. Connect this to 12. Okay, so now we can also set this, right? So now if you are setting different pins, do you want to do something like this, or there is a more one, there are multiple ways of writing this. One way to write is to specify individual bits and put an R. So how you do that? You can use something like this, shifting 1 to 5, so that you can know that that fifth bit will be on here. That is one thing. Can be sure that you are turning on the fifth bit, because the last time I was not sure which bit I was turning on, and you can also do that. So now what will be the R of these two things? So this is the fourth bit turned on, and this is the fifth bit turned on, like 0 to 5. So this will give me the actual time. So I can set it like this, and similarly I can do the same thing for selecting the particular pins like this. And here I would make that 0, right? So instead of doing this, what I should do? Should I do the opposite? You can use the negate operator. So that is one way you can. So if you negate, what will happen? Everything will be uh, everything else will be turned off, right? So what you can do instead of this? You have to and the negations, so that you can do. So when we add the negations, what will happen? Zeros will be staying 0. So that is one way which you can see. Okay, for example, if I want to reset this, what does this give me? This one will give me 0x 000 0, 1, this one. It will give me this. If I are with this for negative, so for setting, it's fine. How will you reset? These two pins only. So now, okay, now let's assume we don't have any other pins, so we don't care what other pins will work to. Okay, so what we can easily do is basically set 0x00, which means all. So x here means hexadecimal. So I just put two zeros. I'm resetting everything. So this will turn on and off things, right? Yeah, basically set and reset. But now the setting it like this will also affect the other pins if there are that are there. For example, now let's do a more complex thing where I want to go like this, turn on, off, like that. Then how do I code? You have to specify it like this. Then if you are specifying it like this, it would get too complex, like the actual values and things like that. It will get too complex. So we, instead of setting b equal to something, we perform an operation on what is there. Okay. So now there are three operations that we can perform. Let's call this set a bit, reset a bit, and toggle a bit. We can perform these three operations. So that will give us control on setting individual bits instead of setting the whole register like this. Right? So how do we do that? So now our idea is to, uh, with this 500 ms delay, what should we do is turn off these two and then turn on this. So it goes one by one. So that's the basic idea. So we'll give the connections. So the connections are fine. Now we have to initialize three things. So this is our basically the setup, right? And this is our loop. Now in our setup we also have to enable this one, which is PB3. So that I can set it like this. So I can select this, right? And one more thing, this AVR library provides a shorthand for doing something like this. So this is kind of this looking big. So they provide another macro which is defined just like this. Define EV. So PV means if you give any arguments like this A, it will put 1 like this. So this BV is a macro. So that is actually defined internally. So we don't have to define that. We can just put BV3 like this. So there is also this thing that is there. So in port, this GPIO ports, you have a very ordered uh, pin numbers, right? So for example, if you go to this, the numbers are very ordered, 0, 1, 2, 3, and things like that. But you see this register, there are no very ordered numbers. So if you are accessing the bits using this number, it would be hard, right? So that's why they defined all these things in the file so that we can, instead of using this number, we can use this one. Okay. So if you see here, the register is defined and also the register bit is also defined, the bit name. So each bit name is actually defined in this file. So if you see MCU CR, which is the control register, we don't need all the bits, right? So all the bits have been named here. So we don't want to do something like this BB3. Instead, we can use PB P port V G 3, the name. So that is one way of doing this. So writing it as this one, or like just PB3 will be also fine. I think this will also will work. Right. Just a minute. I'll add this also here. And that is kind of a short form kind of thing. Let's see if that exists. Yeah. So this is also there. So you can also use this notation, or use port B3 like that. That is kind of long, right? That sets the actually sets the particular thing. So we can use, so this port rating port P is kind of long, so we have also a name like this. Basically does the same thing, right? So now you know this different this similarities between doing this and using this notation, so that you don't need to remember this exact bit positions to set a particular register. You just need to know the name of that bit. Using that you can set that. So now this is fine. You can set it like this: BV5 or PB5 and PV, which is basically bit value of a particular bit. That's what that means. PB4. We can do like this. So now I know which are the bits that I have set as output mode. So enabling that will make this output. So now this register will set it like that. So now our aim is to do a like a loop like this one on, this two off, then this one on, that two off, and this one on, that two off. So that is the idea with the 50 millisecond delay. So what we'll do is first we need to set everything as off, right? So that we can do something like this. I don't think that is necessary. Like initially that everything is off. So what we'll do, uh, maybe we can set it like this. Port P, I'll set up everything is off. 0x00 is an 8-bit zeros. So that is everything is off. So now I'll turn on the first one only. So how will I just set one particular bit in area? I can use port B R equal to, which will just set one particular bit. I'm going to set EV, EV5, and with the delay, and then I'm going to enable 4. So now what I'm doing is enabling everything in order, and then after this I'll be uh, disabling everything one more and add a delay. With this, we can also do like this. Now let's see. So it will be 1, 2, 3, 0. 1, 2, 3, 0. Fine, right? And now we want to also turn off the others when only one per time. Now one, it's accumulating, right? The number of LEDs blinking is increasing. Now we want to just shift the LEDs. Like now the first one will be blinking, the next two will be off, and the second one will be blinking, and the other two will be off. So how do we reset a particular thing? So this is setting, right? So how do we reset? So if you, now we don't want to turn off this while resetting that one, right? We want to just turn off that particular bit. So how do we do? You AND with the negation. To be and equal to the negation of right, just turning off that. So now this won't be affected. So what will be the negation basically? So in this thing is actually 0 B 0 0 0 1, this one, right? Its negation would be bitwise negation. So it would become 0 B 1 1 0 1 1 1. One more one. Yeah, here one more 0. Like this. If we AND with this, what will happen? Only this particular will be off, and this all these things. If you AND with 1, what will happen? If it is 0, it remains 0. If it is 1, it remains 1. So ANDing with 1 doesn't change that other things. That's true for ORing with this also. If you are with this value, what happens? It won't affect the other bits. If the other bit is 1, it remains 1. The other bit is 0, it remains 0. Only this would be changing to 1 in any case. If it is 0, it will be 1. If it is 1, it will be 1. Doesn't matter. And that is what setting means. So this is setting. And this is resetting. Turning a particular bit off. Right. So now we'll turn off this. And in the next thing, we'll also turn off this. Basically ending with the negation. Turning off that. And what else? Now here, everything is turned off. Oh, that is fine. Now let's see how it goes. Right. So that is the. So now let's take a different approach. So now our pattern will be like this. So I am assuming these 3 LEDs are 0, 1, 2, 3 bits kind of thing. So now our thing will go like what 1 1 0, then 0 1 1, then 1 1 0 1. It goes like this after this delay, and then finally 0 0 0. You can have that. For 0 0 0, if you want to affect only these 3 bits, so here we are setting all the bits to 0, right? We are not only affecting that 3 bits, it also affects other. How do you just disable these 3? Or here you can just disable this one, as we know particular thing is there. But how do we only affect the certain bits? You just have to OR it or AND it with this particular things. So for example, if you want to set multiple bits on, how you do? You use an OR. So in the first thing we have to set the first 2 as OR, which is the 5 and 4 as set. We have to set the 5 and 4. So you can do an OR with this like this. And then maybe we'll do this. We'll do the opposite of this. For example, like this. So we have to reset these 2 and set that. How do we do that? So in resetting, so for example, we have to reset these 2 things. We just have to AND, right? I am resetting 4 and this. Now we are resetting. What? So this just means reset. We are turning off. We have, if you are using digital, right, high and low, you can just turn on and off one particular pin, right? But in this way, with one instruction, you can actually turn on multiple things together. I'm resetting those 2 and setting this, which is 3. This one. I'm doing it like this. And now what I can do, now I am just, for this one, I just have to turn on P5. So for that, I'll just set P5, right? It is already on, so I don't have to worry about that. And after that, here, I am actually setting everything to 0. If I don't want to set everything to 0 and just reset these 3, what should I do? instead of this, I use the AND thing for resetting. With these three, okay. So let's see. So first 110, then 001, then 101, then 00. So doing it like this actually doesn't affect the other pins. If you just all zero, other pins will be also affected, right? So for example, you can also verify that using adding another LED and just doing this. If you do this, only there those three will be affected. So for an example, now this code doesn't affect any other LEDs. To show that, what we can show is add another LED, which is 2 in this 2, and we are going to run this code while this will be always on. Using overlapping LED wires, that might be confusing, but uh, I'm saying that this 13, 12, these three are connected like this. And now what we have, uh, yeah, now we can just turn it on. We'll set it to output mode like this, 2, and then this would be, we'll just turn it on. So to just turn it on, what we can do is, so what does this do? Instead of putting R equal to or AND equal to, I'm just putting equal to and this, which means only that this LED will be turned on, and we are not keeping our hands on that during this loop. So if you see throughout the program, this will be always turned on. But if you are using this instead of doing this, if you are setting this to 0, you will see that will be also affected. And that won't turn on after the first loop. See? So basically, if you are with this, you set. You add with the negation, you reset. So is that clear? Any doubts do you have till now? Because I hope this itself will be kind of confusing. So do you have any doubts? Or you want me to repeat the part of this? Or if you don't understand any of this, you can ask. Instead of using VV, you can also use this kind of things if you prefer the shift notation. This VV is defined in basically this AVR library. That's why we are using that. That's also a common thing that people use. Or if you don't want that, you can use that. And if you can also define your own way of writing that using defines, if you feel that is kind of too much. And you know how we are getting these register names, right?
Sir, can you say how to get the register names?
That is here. So if you see, this is the so what the board we are using is Arduino, right? And the microcontroller that is present here is actually Atmega 328P. So this is the pin diagram of that, which I downloaded from here, right? The pin or PDF from the docs, and you have the Arduino datasheet. But now we are not using the Arduino library, right? So I am directly using the registers from the Atmega 328P, which is there in this Arduino. So I have taken that datasheet. This datasheet contains everything about this 8-bit AVR microcontroller Atmega P, which is present in Arduino. And I am using the AVR libc. So if you see, instead of main sketch.ino, I am using main.cpp. So if you do that in walkv, it will automatically detect that you are using a C file. So it won't treat that as an Arduino sketch. So that pre-processing of that Arduino sketch won't happen there. But here you can include whatever you want from the AVR library. So this AVR has different things like interrupt, sleep, just like, so these are very basic things. So what the AVR library has is, if you see, so this is the header file, that avr.io header file. You see what it has is basically another include statements for particular boards, right? So if you want to zoom it, oops, you can see this, right? This is just an include statement with the define of the board name. So if you see at Mega 328p, you can see that this is there in this file. And if I open this and search that file, that file actually has the value definitions and the addresses for this port B and everything, these things. And this only has the number mapping, right? But how do we know which number does what? That's why we need the data sheet. In the data sheet, it has many things. If you see this, this is a pin description, the first one, the pin configuration. So if you see this diagram here, so this microcontroller comes in different shapes. So these are the two shapes that it comes in, and Arduino uses a different shape which looks like this, which is suitable for soldering in a breadboard kind of thing. So actual models are very small, so that are not solderable kind of thing. So, but you can see these pins, DD5, 6, 7. These are the port names and the pin numbers that are also present in one. You get to know the names, like the port names, by looking at this. If you see, the D8 to D13 is connected to PB0 to P5. This thing. So if you want to control these 5 things, you can just use this PB port B and this 5 registers to control. And if you see this, the 0 to 7 is connected to port D. So there are different I/O ports that are present in this microcontroller, and and some of those are there. So if you see here in this data sheet, you have the I/O ports, how the I/O ports are there, and what are the things. So in every section of this data sheet, you will find a register description. So if you see the I/O ports, it has register description. If you see the external it has a register description. And here I think something like that, system control and restart also have a register description. So all of these section in this thing will have a register description. If you see, you will get to know which are the registers present in that particular thing. Okay. And now, how do we configure? So there is a section on that. How do we configure the pins? Right. So to set a pin, these are the different configuration. So here they will use a notation like this, DDXN, where X can be A, B, C, D, that name, port name, and N will be the particular bit. So if you see from the DDRB diagram, so this is DARB, and this is DDR, DDB7, this is DDB0, which is the 0th bit. So each bit will have a name, and register will also have a name. So this port C is a register, and this is the bit name. And if you see this one, this is the register name, MCUCR, which is microcontroller control unit. Like that is MCU control register, that thing. And these are the bits, and each bits will have name. And all these names and these numbers are defined in our library file. So that's why we are able to use those numbers. See, MCUs are this, what is the address of that, and what are the names of those particular bits that is present there. MCUCR, in MCUCR, if you see, what are the bits are there? IVCE, IV select, PUD, PUDC, PUX, and you can see that in these 5 names, right? And we have all the things here, and details about things can be found here in the register description. So how do we set the register? So that's why we saw this one, configuring. So in configuring, you have to read this section and how we can configure things. In short, the idea is this. So there are three input modes and two output modes. In output modes, if you see, the DDXN will be 1 and the input modes it will be 0, which means what DDXN is? DDB something, some bit, which corresponds to setting the input and output mode of a particular ports bit. So for our example, DDB, here we are setting DDB, DDBR here, DDRB, which is the data direction register, and for the port B and these things. So here you can use this notation also, DDR, sorry, DDB0. Basically, that is the name of the bit. So you can use that DDB0. And sorry, it is B5. B5. You can use the number if you know the number, or else since here it is all same, DB2 is same as DB2, so we can use like this. Sometimes it may differ, so it is good to use the actual. So you see that are the DDB, DDB, yeah, these things. See DDRB, this is our register, and these are the position bits of the position value, and the name of the bit is given here. So if you want to do selection or prediction, like resetting or reset, you can do like this. So that is what we are. So here we are setting everything, which means we are turning on to everything into output mode. If you don't do this, it will be in input mode, right? So we are not able to tell anything about it. And this port B register, as you see here, port XN. How do we set that? In output mode, there are two values, the 0, 1, which sets the, if 1, it is high, and if it is low, it is 0, it is low. The high and low that we know. In input mode, there is another register, which is PUD, like another bit, MCUCAR, which sets it to a particular pull-up. This is for pull-up thing. For example, he is pull down. That's what this means. PUD, pull down. So if you see the register values, MCUCAR, and it has this value, pull up disable. So if you turn on, it will be disabling the pull up. If it's turned off, pull ups are enabled. It's kind of that. Okay. When this bit is right 1, even if the port registers are configured, enable the pull ups. Okay. So that is kind of a, what do you say, a common bit for those things. Okay. So that using that you can actually set. So this is about the GPIO registers. Basically, it is quite easy enough. But you can also use timers, and we will be also seeing doing all these things in the later tomorrow maybe. Yeah, tomorrow also we'll be having this session. There will be actually dealing with the timers, and I'll be using these registers to control the values of the timers. So there are different bits that are present in the timers. GPIO is fairly simple enough, which has more common names. But here you will see different registers and bits like this, and we'll be dealing with this. Okay. So now you know how to do this. And one more thing, we'll be sorry, this is not this one. This one. One more thing. Now we saw set and reset, right? Okay. Before that, is that doubt clear? How do you find the registers?
Yes, sir.
And now about toggling. Toggling, how do? You do something called an XR. So let's see how that works. So let me have something like this. So XR, you know, right, how it works. It is 1, sorry, 0, 0. If both are 0, it will become 1. And 0 1 will be 0 1, sorry, 0, and 1 0 will be 0, and sorry, I think I'm missing one. This is 0 1 1 and 1 0. So both are same, it will be 0. Both are different, it will be 1. That is how XOR works. Right? Assume you want to toggle a particular bit, right? You XOR it with this value. So for example, let's take an 8-bit value. So 1, right? If you want to toggle, you XOR it. So I want to toggle this particular bit only. So I take that bit value, only that, and I can do. So what will be the operation XOR will give me? So if you XOR with 0, what happens? If you XOR with 0, the input stays. See? If you assume this is the input and this is your value, you XOR with 0, the input stays. If you XOR with 1, input toggles. Now can you get the idea?
Yes, sir.
So with that, all these zeros, if you XOR with anything, so if you XOR this 0 with this 1, it will be 1. It doesn't change that. But XORing with the 1 will toggle this bit as an out in the output, right? That is the basic idea of using XOR to toggle it. So the idea of setting, resetting are simple enough. Like setting will be ORing with a particular set bit, and ANDing with the inverse of the set bit is resetting, and toggling. So let's toggle things, right? So what we'll do is we'll do one thing. We'll just turn on and off in some order. Okay, we'll just toggle the first this 5, and we'll toggle 4. This is toggling. We'll toggle the bits like this. 4 3, and now let's see. Bits are toggling when the time comes, right? You can also toggle multiple bits. How do you do that? You have to OR it with this. You want to toggle 2 bits at the same time. You can do so. Let's do something like that. So here it will be 4 3 3 2 2 5. Okay. Let's see how this works. It's toggling the continuous, so it's kind of something like that. Okay, just a minute. So is this clear? Any doubts till now? How we are using GPIO and how that bits work, and about set, reset, and toggling. Toggling a single bit and toggling a multiple bit, and setting multiple bits and resetting multiple bits. So this is the basic bit manipulation that we'll be doing in any embedded programming like things. So now we know that this kind of approaches exist. Why do we need to use an Arduino, the Arduino.c, the sketch.ino? How does that help? That helps in learning and prototyping. So if you want to quickly try out things, you might not want to go to the data sheet and find the register values and do things, right? You have a concept and you know this Arduino library is supported for all these values. And using AVR also, you can do a kind of thing like the similarity will be there. This bit names, most of the AVR microcontrollers, the names of the bit might be similar, but the actual details will be different in different boards. So, for example, there might be a timer one in one board and a timer two in another board. So those kind of changes may exist, and the number of ports this will be slightly different, but you don't know, right? So in Arduino, it encapsulates everything to a same function. You don't have to worry about the analog things. Like if you want to do analog read write values, it becomes tricky over here. So for example, it takes time to implement, but one thing you can do is you can try your implementations. So that is not for prototyping. Want to quickly try out things, use Arduino. If you want to optimize and you want performance, those kind of things, is your application performance intensive? Those cases you can actually work on this. And people also have some standard libraries built on this. You can refer to that, check that code. Maybe you will learn something from that using that method, and those kind of things are there. So you see everything is there. This is the analog to digital converter, and you see there are many bits around here. So actually implementing the actual conversion things and getting the values might be take time. Like you need to learn all these registers, right? So for timer, you have certain registers. I actually it took me 2 full days to by looking at this to understand everything. Now that I have summarized, I might be able to teach that to you tomorrow. But if you want to do this in a different board, you will also take some time to get to know about the registers. But one thing is, when you learn something, it you can associate it with that, right? The other things that you learn, there will be only changes that you learn. For example, once you have learned the pin mode and stuff, like how do you do in the Arduino, now you can associate what I have taught with that, right? So then you are only learning the changes. So in that way, going from a higher level library and deep down like this will help. Okay, so now we don't go here today. We'll go here tomorrow and we'll look into that. Right. So you can also use this thing to do most of our exercises. What you can try to do is in the GPIO exercises that I have given, and that's a practice that you can try doing with this library, the basic uh, things. Okay. So then using that, you will be able to do this. So here you will have all the things that are there. IO, time, interrupt, everything, delay, sleep is also there, but I'm not sure how to use that. You just have to look at these things. So there are these registers that have these things, structures, and okay, this time offers different timings that we know. This is actually the what you say. It provides us the real time thing over here. And what are the other libraries do we have? Do we have something like this? Yes, maybe we'll search like okay, it seems somebody have implemented their own version of it using that. Maybe they would have used a timer to do this. Yeah, it's a timer. So they are using a timer interrupt to actually count the millisecond. So we will be also doing this tomorrow. For that, we need to learn this timer library and the registers of the timer to measure that time length, the millis function that does. Right. Okay. This one is this one, and one more thing I want to discuss, like slightly tell about is you will be also doing one of this STM32 board thing. Like you are one of the exercises involves STM HAL, and you will be also doing GPIO there. So for that you will be needing something. One is called the CubeMX STM32 CubeMX. So this is a code generator. So you are setting the bits like this for this AVR, right? AVR is quite simpler and you can do it easily. So this STM cube is for the STM boards, the STM32 boards. It can generate the configuration code. So for example, here in our case, the configuration code is this, and this is our configuration, the mode, setting the mode. So this can be actually done visually. So I have installed this CubeMX on my system to show how that will look like. Right. So there is this things, yeah. This. So this HAL actually creates a file called IOC. Okay. So there is this IOC files. Just a minute. The IOC files. So basically, this is the ST32 microcontroller. So C031 C6 is the model that is present in WalkV. So here you can actually select the GPIO pins and set up the configuration, the pull out mode or pull down mode, everything. So here if you see PA5 is actually set in input output mode. You can change it like that. Pull up or pull down you can set. So there is also this operating speed that you can configure like this. So here is also this PA5, which is actually the GPIO pin in the STM board that you can configure. So you can just click here and set it to some of the mode, like you can see this right easily. Yeah, if I go and I can set it as in GPIO input, and that phone pin will be configured as GPIO input mode, and everything will be easily configured. And also after that you can actually generate code. So there are certain options for generating code in this project manager. So you can actually set which type of thing you want, things like that. Here you can select the application structure. Basically what it will generate is, it will generate some certain set of header files and the main.c file, which will have the initialization code. If I do this now, I have already configured these two things, right? It will give me this core source main.c, and you can see the configuration, all this GPIO pin 5 for that particular board. So this is actually the HAL, the hardware abstraction layer. And as you see, there is a library for this AVR, right? And there is Arduino libraries there. Similarly, there is this HAL library, which is especially for programming the STM boards, is there. Here, basically, what you have, if you see, this is the things that you configured, right? The PA7 in input mode and the things. So that will, this CMX will generate all the configuration code that you need. You just have, you can do it visually instead of looking to the data sheet. STM provides an easy way for their boards to do things. So STM is a kind of uh, industrially used boards, that is. Arduino boards are very low cost, small, for some hobby projects, simple projects. Okay, so that is that. Your application request. So this STM boards are based on ARM microcontrollers, not AVR microcontrollers as Arduino is. So there are differences between those things also. So this ST microcontroller is the vendor or the company that creates these boards. And Arduino, you know, that is the Arduino company that is creating that Uno boards and things. So they provide this tool for generating configuration code for their boards. you can actually select the board. So if you I have already configured the projects, that's why you are able to see the thing coming up. If you are creating a new project, you will be redirect to the board selection window and things like that. Here you can select the board that you are looking at. So for our thing is this, and this is our board. This is the MCU that we are going to select. So this is the board that is present in workv. So I'm selecting that board. You select this, configuration for that will show. So this is empty configuration, nothing is configured, and you can configure the timers easily like this. I select the tin one, what is the mode that I want in easy manner like this. So this is also the text and things are visible here. Not sure size. So STM Cube is just a tool for generating this configuration code, and also you see now this looks better. I think. And there is a Cube IDE which also has programming abilities that if you want to programming and upload it like that you use an Arduino IDE, there is a STM Cube IDE that helps you do those things. Now we have a bigger font. So see this, I think. Trim one, you will get to know the modes easily, and you can just select it and just generate code, and it will give you the configuration. So this kind of visual tool that this uh, company provides. Okay, so now that's all the introduction about that. And this is also, if you see, there is basically this main dot thing and a while loop here where you will be doing. And these are basically initializing the things. So this is the HAL library initialization, configuring the system clock, GPIO, and these are the other header files that has like some other initialization code and things like this. This is the systic handler, which means it handles the system clock ticks. And to run a code that is written here, basically this what you can run this code also. So to do that, you just have to upload this main.h and main.c to workv. If you upload, copy this whole thing and paste it, create two files and put it in workv, you will be able to do the LED blink here also. So shall we do an LED blink with that? Today I think we can close with an LED blink in that. I hope this is clear, right? You can try doing this. And now we create a new one. So this is that thing. So here also you can use Arduino code using sketch.ino. If you can run the Arduino code, you might be doing that. So now if you want to do the main.c, the configuration is kind of easy if you are doing it with bit level. It is easy in Atmega. It has some registers, and also STM also has this registers. If you want to look at their data sheet, so let's see STM 32 C0. This is their HAL manual for. So this is the HAL API manual, which means this has a set of HAL functions that can be used for this series of STM microprocessors. You see, they also have these things like GPIO. So what are the? If you see, these are the things actually set up by the CubeMX. CubeMX actually sets these things, all GPIO in it, and what those functions does. If you want to toggle pin, they have a function for that in this hall. And if you want to look at the registers, you can. There is another manual for that. STM 32C0. We go here. Uh, SRC supports and 66. Can go to the part number. So this is that microprocessor. details about the microprocessor will be there, the documentation, and you will have the product specification. So all the things that are there, user manuals. So this uh, this is the programming manual that is this one. This is the programming manual. Programming manual has different things about the. So there is the HAL description and the peripheral description. So this has things about how you code and things, which are the IO ports, how things are there, some description about that is there. Uh, so we will be using this HAL library to interact with, if you want to write code with HAL, STM HAL. Okay, and let's see. In this one would be the data sheet, DS for data sheet. So now this is the data sheet for everything. Pinouts has different things. This is the pinout. This LFP48. If you see the CubeMX, we chose that board actually, so you can see the same pinout coming over there. See this one, same things. PA2 to PB12, it's there, same thing. LFP48. This is what we have. Okay, and there is also this registers and things are there. The name of the register is PP12 thing. This is the alternate function that we use in assignment. Let's go here. Functional overview. Yeah, here we have timers, GPIO. So in GPIO section, it just give an introduction about what the GPIO is and things like that. In this page, this doesn't have the registers information. This doesn't have the register information. It might be the another manual. See if we can find that reference manual. Okay, yeah. This has the registers. You see, for GPIO, there are these registers. So GPIO here is kind of complex than the GPIO in there. You can see different mode bits and the output bits, output type bits, speed bits. So it can operate in different speed, pull up and pull down bit registers, PU, PDR registers, and GPIO IDR, input data registers. So this and output data registers. This is where we actually set the value. If you set the value to the output data register, it will actually change the output value. And there is this set reset registers. Here also using this also you can set or reset a particular register just like we did it. Right? So this is the reference manual, contains the register level details. If you want to code in with the register names, you can use this. Okay, GPIO is there and many things. So for different, so if you get to know this common functionalities that is available in every board, so most of this common functionalities like GPIO, ADC, UART, SPI, timers, and what we have, uh, the serial UART, SPI, and I2C communication protocols. So those kind of things will be by default mostly in every board. But how the level of control each board gives is different. And also the power usage of a particular board and the customizations that we can do with the particular board is different. So for simplicity, we'll be doing Arduino timers in this because as far as now, the STM timers are actually not supported in work right now. So we'll be learning Arduino timers in this throughout this session. And in the offline lab that you have, we'll be dealing with STM timers, doing exercises on that. So okay, let's do the HAL blink code. I think we have a configuration code generated, main.h, and don't need this now. So I'm just resetting that. This is all we need. Generating code. So if I want to do this, just take this. So I have to copy this main.h just here. I'll rename this to main.c and I'll add a file main.h. We paste the main.h here. So if you see, they have this kind of notice. So I hope we shouldn't remove this. So we are not going to remove that because it's generated by their product. Okay, and next one is main.c. This is the source file. We'll copy that. Okay, and now this is the GPIO init functions that are there. Now to blink this, what we are going to do is basically call toggle pin. What is the pin? PA5. We toggle that. So that is the function name that we have. No, all GPIO toggle pin. This is the function name. So we will use that. Right. We toggle this and use all delay. There is a function called all delay, which is described over here. This one. This function uses milliseconds to create a delay. So we are going to use that. And actually PA5 is also connected to the internal LED core in this board also. This board is kind of Arduino compatible board. You can see all the Arduino boards corresponding thing are there, and there is also this additional pins that are there. PA5. Okay. PA5 is not defined over here. So let me check. So this is actually is it PA5 PB5? For that, let's verify the diagram first. The different things. Okay, let's see, this is the block diagram, all the CPU ports and how they are connected, the timers, how they are connected is present over here. Let's see where we saw the pin diagram. Okay, we'll go here and see. This PA5, right? Okay, here you can use, you can't use it like this. You can, I think, you should use TPI. Okay, here. we have to give GPIOX and pin number like this. So it would be uh, GPIO P and pin number is 5. Sorry, it's B5 or A5? A5, right? What is it? A5. So A5. Let's check. So when you want to code in a thing like this, you might want to learn all these things. So getting to know what are the features, and if you have implemented one thing in any of the board, it would be easier for you to implement that thing in another board. Style. Yeah. Uh, okay, it should be great. Okay. Uh, are you sure that it is connected?
So I think we have tried GPIO pin 5.
Sorry.
GPIO A
Oh,
and
here,
then
here.
GPIO pin 5.
Okay, that name of that. See. Okay, GPI pin. Okay. Okay, parameter can be GPIO pin X, and X is the number, can be 0 to 20. This will be A to F for write pin, read pin, and toggle pin. So for multiple state, there is another way, like in one way, like then yeah, give a pin set also, it seems. Now it's breaking. Yeah. Okay. This is basically how you generate HAL code and run a workflow. You can have to add code at different sections where that is needed. Okay. So that we can stop the session.
Okay, sir. Thank you, sir.